Isn't it remarkable? A breathtaking sphere suspended in the vastness of space. We live on a world that feels solid and permanent, a foundation beneath our feet that we often take for granted. Yet beneath our feet and above our heads lie hidden realms of heat, pressure, and invisible air, forces constantly at play. This planet is built in layers, each with a unique role, a carefully constructed masterpiece of geology, all working together in a delicate balance to create the conditions for life, a symphony of interconnected systems. To truly appreciate our place in the cosmos, we must journey through the very substance of Earth, a voyage to the center of our world. From the crushing core, where pressures are immense, to the edge of space, where our atmosphere fades into the void. Each layer is a chapter in Earth's epic story, a geological record etched in stone and time, shaping continents over millennia, driving weather systems and shielding us from cosmic dangers with its magnetic embrace. Imagine Earth as a cosmic peach, a simple analogy to understand its complex structure. We live on its thin skin, the crust, a fragile layer teeming with life. Below is the thick mantle, a sea of semi-molten rock, then a layered core, a metallic heart generating our planet's magnetic field, and above, delicate atmospheric veils, protecting us from the harshness of space. This structure is the result of billions of years of cooling and change, a slow, relentless process of planetary evolution. A dynamic system still alive today, constantly reshaping itself through volcanic eruptions and tectonic movements. Our exploration is an act of wonder, a quest to understand the forces that have shaped our home, peeling back the familiar to reveal the extraordinary, uncovering the secrets hidden beneath our feet. Using seismic waves to peer into the depths, analyzing magnetic data and utilizing satellite imagery, we'll visit places no human can go, venturing into the heart of our planet. We'll discover solid iron crystals forged under immense pressure at the Earth's core, rivers of liquid metal swirling and churning in the outer core, and slow-moving rock currents, the engine of plate tectonics in the mantle. We'll ascend through skies where weather is born, witnessing the power of atmospheric forces. And meteors burn in fleeting streaks, a reminder of the cosmic environment surrounding us. This is the story of Earth, from its heart of iron to the edge of space, a grand symphony of geological processes. Our journey begins, a voyage of discovery. We embark by looking both down into the mysterious depths, exploring the unseen realms beneath our feet, and simultaneously we gaze up into the vast expanse of the sky, reaching for the heavens. Beneath us, deep within the Earth, are four main layers, each with its own unique characteristics. First, the solid inner core, a sphere of iron under immense pressure. Then the liquid outer core, a swirling ocean of molten iron. Surrounding that, the vast mantle, a thick layer of hot, dense rock. And finally, the thin crust we stand on, the outermost layer of our planet. These are the fundamental building blocks, the very foundations of our world. Above us, the atmosphere, a protective blanket, forms 5 main layers, each playing a vital role. Closest to the surface, the troposphere, where all our weather occurs. Then the stratosphere, home to the ozone layer. Beyond that, the mesosphere, where meteors burn up. Next, the thermosphere, where the aurora dances. And finally, the exosphere, the boundary with outer space. Each layer, both below and above, is a distinct environment with a critical role to play in the grand scheme of things. As we venture downward, pressure and temperature soar to levels that are hard to imagine. The core is a furnace, a source of unimaginable forces and energy. As we move upward, the air thins dramatically. Temperatures fluctuate wildly, and we gradually approach the cold, dark void of space. These seemingly separate realms are, in reality, deeply and intricately connected. Heat emanating from the core drives the process of mantle convection. This, in turn, moves tectonic plates, shaping the surface and creating mountains. The liquid outer core's magnetic field acts as a shield, protecting our atmosphere from the harmful solar wind. Volcanoes, in their dramatic eruptions, release gases that eventually become part of the very air we breathe. Earth is not just a collection of separate parts, but a single integrated system. Its deepest interior has a profound influence on the highest reaches of the sky. Our planet is a beautiful, complex machine, a testament to the power of interconnectedness. Deep beneath our feet at the planet's center, over 6,000 kilometers down, lies a realm of extreme conditions and hidden secrets. It's a place we can't directly reach, yet its influence shapes the world we know. This is the inner core, a solid sphere composed primarily of iron and nickel, a dense metallic heart at the Earth's very center. The temperature here is staggering, reaching levels as hot as the sun's surface, an environment of unimaginable heat. Yet despite this intense heat, the iron remains solid, locked in place by the immense pressure exerted by the weight of the entire planet above. This heart is not static. It's a dynamic entity, constantly in motion. It spins on its axis, and remarkably, it possibly spins at a slightly different rate, perhaps even faster than the rest of Earth. Its rotation is intimately linked to and influenced by the powerful magnetic field generated by the swirling liquid iron of the outer core. The inner core is not a fixed entity, it's slowly growing, evolving over vast stretches of geological time. This growth occurs as iron from the molten outer core gradually cools and freezes onto its surface, solidifying layer by layer. This process is incredibly slow, adding only about a millimeter per year to the core's radius. We can't directly observe this growth by drilling into the Earth. The depths are simply too great. Instead, our knowledge comes from listening to the subtle echoes of seismic waves generated by earthquakes. These waves travel through the Earth, revealing the core's solid nature and internal structure through their patterns of refraction and reflection. Recent research has even suggested the existence of an innermost inner core, a distinct region within the core itself. In this region, the iron crystals appear to be aligned differently compared to the rest of the inner core, hinting at a complex history. This unique alignment may be a relic of a dramatic event in Earth's early history, perhaps a massive collision or a period of intense geological upheaval. The core's structure, therefore, is more than just a physical arrangement. It's a secret history book written in the language of minerals and pressure. It's a record of Earth's evolution, etched in iron over billions of years. Our understanding of this hidden world comes from carefully interpreting the subtle vibrations that ripple through the planet, carrying information from the deepest reaches of our world. This process is not unlike how a doctor uses ultrasound to image the inside of the human body, using sound waves to create a picture. The inner core's slow growth, a testament to the immense timescales of geological processes, and its unique layered structure, are crucial clues that help us piece together the puzzle of Earth's evolution. It is in essence a world within a world, a hidden realm of extreme conditions and ancient secrets. It's a dynamic engine, spinning at the very center of everything, driving processes that shape our planet's surface and environment. The story of Earth's heart, this solid iron core, is only just beginning to unfold. And with each new discovery, we gain a deeper understanding of our planet's past, present, and future. Moving outward, we enter the outer core, a vast ocean of liquid iron and nickel over 2,000 kilometers thick. Here, temperatures remain extreme, but pressure drops just enough for metal to flow. This churning liquid generates Earth's magnetic field through the geodynamo effect, turning our planet into a giant electromagnet. The magnetic field forms the magnetosphere, shielding us from the solar wind and preserving our atmosphere. The outer core's flow is chaotic, causing the magnetic field to wander and even flip every few 100,000 years. Ancient volcanic rocks record these reversals. Surprisingly, the outer core's viscosity is low, more like water than syrup, allowing rapid, complex motion. This watery river of metal powers our planetary shield. Without it, Earth would be stripped bare by space. The outer core is the engine of life's protection. Above the outer core lies the mantle, Earth's largest layer, making up most of the planet's volume. Though solid, the mantle flows slowly over millions of years, driven by heat from below. This movement, called convection, circulates rock in vast, slow currents, driving plate tectonics. Tectonic plates float atop the mantle, colliding, pulling apart, and reshaping continents and oceans. The mantle is divided into upper and lower parts, with a weak, partially molten asthenosphere enabling plate movement. Heat transfer and convection here shape the surface world, building mountains and ocean basins. Deep within, minerals like ringwoodite may trap vast amounts of water, possibly as much as all Earth's oceans. This hidden water could influence volcanism and the water cycle. The mantle is a slow-moving engine, shaping our dynamic planet. The deep Earth may be far wetter than we ever imagined. At last we reach the crust, the thin solid shell where all life and history unfold. The crust is incredibly thin, just 5 to 70 kilometers thick, varying between ocean floors and continents. It's fractured into tectonic plates, constantly moving at the speed of growing fingernails. These movements cause earthquakes, volcanoes, and mountain building. Oceanic crust is young, dense, and made of basalt, constantly created and recycled at mid-ocean ridges and subduction zones. Continental crust is older, thicker, and less dense, mainly granite, with rocks billions of years old. Despite being our home, the crust is less than 1% of Earth's mass, a fragile veneer atop immense forces. All of human history has played out on this ever-changing skin. Our solid ground is anything but static. The crust is a delicate platform for life in a vast cosmic ocean. It's a humbling perspective on our place in the universe. Now we ascend into the atmosphere, starting with the troposphere, our home layer up to 15 kilometers high. It holds most of the air and water vapor where all weather happens: clouds, rain, winds, and storms. Temperature drops with altitude, making mountain tops cold. The troposphere churns with convection, driven by the sun's heat. The tropopause caps this layer, keeping weather below. Above lies the stratosphere, from 15 to 50 kilometers up, a calm, layered region with little weather. Here, temperature rises with altitude due to the ozone layer, which absorbs harmful ultraviolet radiation. The ozone layer is our planet's sunscreen, making life possible. Rare nacreous clouds shimmer in polar regions, glowing with iridescent colors after sunset. The stratosphere's stability and beauty remind us of the complex chemistry protecting us. Without these layers, life on Earth would not exist. The atmosphere is our invisible shield. Higher still, we enter the mesosphere, 50 to 85 kilometers up, the coldest part of Earth's system. Here, meteoroids burn up as shooting stars, protecting the surface from constant bombardment. Above is the thermosphere, where temperatures soar to 2,000 degrees Celsius, but the air is so thin you wouldn't feel the heat. The thermosphere is home to the auroras, northern and southern lights, created by solar particles colliding with atmospheric gases. The International Space Station orbits here at the edge of space. The mesosphere and thermosphere are realms of extremes, freezing cold, searing heat, and dazzling light shows. These layers shield us from space debris and solar radiation. They are the boundary between Earth and the cosmos. Our planet's upper atmosphere is both a barrier and a window to the universe. Our journey ends in the exosphere, the outermost layer where Earth's atmosphere fades into space. Here, atoms drift for hundreds of kilometers, some escaping into the cosmos. Satellites orbit in this vast, nearly empty region, the final breath before the silence of space. Earth is not a perfect sphere, it bulges at the equator, affecting both the crust and atmosphere. Mantle plumes, columns of superheated rock, rise from deep within, creating volcanic hotspots like Hawaii. From the spinning iron core to the last wisp of hydrogen Earth is a symphony of interconnected systems. The core's heat drives continents, the outer core's magnetism protects the air, the atmosphere shields and sustains life. Every layer plays a vital role in making Earth habitable. To understand these layers is to appreciate the delicate architecture of our home. Earth is a magnificent world in a vast, often hostile universe.